So here's the jogger on the track problem. It says the jogger is traveling in uniform circular motion with a period of 30 seconds. And the track radius is 18 meters. And we got to figure out how fast is the jogger going. What is the speed? So the speed is the magnitude of the velocity at any point. And we know the simple equation for velocity is change in position over change in time. So we basically have to figure out what is the total distance traveled in one rotation around the circle. That's our delta x. And then we have to figure out the time it took to do that. So if you're following on the lecture slide, this is 1A. And part B is figure out the total length traveled in one circle around the track. Well, that's just the circumference of the circle. So that the total distance, and note, this is not, I'm writing delta x, but this is not displacement here. This is actually distance, because we're finding speed, not velocity. Yeah, I know it's a little hairy. But anyway, that total distance, the circumference of the circle, is just 2 pi times the radius of the circle, which in this case is 2 pi times 18 meters. 113 meters of distance traveled. And now we have to figure out the delta t, the time it took to do that. And all we do for that is just to recognize that when it says here that the period is 30 seconds, that's the definition of period, the time it takes to go one revolution, one time around the circle. So it is just 30 seconds. So we can go back up to that simple equation for velocity and plug in these, or I guess I should say speed in this case, and plug in those values. And we can get an answer. So part 2 is to derive a general expression for the speed, or the tangential velocity, which is what we just found for a specific instance, but we want to derive a more general expression in terms of r and t. So where we could just plug in whatever radius of a circle that we're dealing with, or however long it takes to go around in that circle. So we start with this. And we saw that delta x is 2 pi r, so we can go ahead and put that in. And that distance was for one specific rotation, one particular rotation. And so that time has to correspond to that has to be the time that it took to go that distance. So this must be the delta t for one rotation also, which is by definition the period t. So we've kind of derived an equation for tangential velocity of something moving in a circle. R is the radius of the circle, the t is the period.